compare the two pieces of software by switching between them during the same imaging session. And I did that using the equipment you see here. The scope I used was my trusty old C11. And with the C11, I have a flip mirror and a reticle eyepiece, and that allows me to get the planetary images on the chip, even the smaller chips, pretty easily once the reticle is lined up with the center of the chip and lined up with the finder scope. So, and then in between the camera and the flip mirror, I have the ADC, the atmospheric dispersion corrector, which is a couple of little polarizing filters that you can rotate to get rid of the color aberrations that occur when the planet is fairly low in the sky, like Jupiter and Saturn are. And then the last component, obviously, is the camera. And for these comparisons, I used my brand new ASI 294MC. So the two programs that I wanted to compare were FireCapture and SharpCap 3.1, and I just thought I'd list here the links to those sites if you don't have that software already. They're both free. SharpCap has a pro version that you can pay a little extra for, but I have the free version, and that works pretty well just for planetary imaging. So to acquire the images, as I said, what I did was get the planet on the chip of the camera and then switch back and forth between the two software packages so that the data was collected in approximately the same time frame. Not always, and you'll see some of the results of that as I go along. So for Jupiter and Saturn, I collected either 3 AVIs or SERs. SharpCap seems to work a little better with the SERs, so I use that. But for each of those, Jupiter and Saturn, I collected 3 video segments and then average those together in WinJupos. So for Jupiter, I used 30-second data collection intervals. For Saturn, since it rotates slightly slower, I use 60 seconds. For Mars, I only collected a single AVI through each one for 3 minutes. And in each instance, what I did is adjusted the frame rate for the camera by adjusting the gain and exposure to try to get the maximum frame rate that I could obtain. And I did this with my older laptop, which just has USB 2 ports. So that was one of the constraints that I was operating under. I've since gotten a new laptop, but I haven't really had a chance to use it with the camera yet. For the image processing, I processed each.
Greg,
yes.
What frame rates were you able to get?
I'll show you that here in just a second.
All right.
But for the image processing, what I did is I processed the images as close to identical as possible. And that is, I stacked them in auto stacker. I used 1.5x drizzle because that seems to give a nice, slightly enlarged image and smooths out the images somewhat. And then I used the best 25% of the frames that I was able to obtain at the maximum frame rate that I could get. After I stacked them, I applied wavelets in Registack 6 and adjusted the histogram to brighten up the image and adjust the contrast a little. And then for Jupiter and Saturn, I used WinJupos to align the 3 sets of images and derotate them. I didn't do that for Mars, although you can do it for Mars as well. WinJupos supports all of the planets, and it's particularly helpful for Jupiter, which rotates rather quickly. And finally, I sharpened the images in Photoshop 6 using a couple of different sharpening tools, Topaz, Sharpen and Photoshop's unmask tool. And then I boosted up the color saturation using another add-on, Nik Visa. So the images were all processed pretty much the same way. So this is a screenshot of when I was collecting the data for Mars, and I just thought I'd briefly show you what's involved. This is for FireCapture. The FireCapture has all of the controls over here on the left-hand side, and then there's a display of the image as it's being captured on the screen, and there's some controls up here so you can adjust the size of the image for focusing, etc. So the main one of the main controls that you have in FireCapture is the ability to determine what's the region of interest, or ROI. And you do that in FireCapture by drawing a box around the planet. This makes it very useful because the smaller the box, the faster the frame rate is, because you're not downloading the entire chip. You're just downloading the subframe that you've identified by drawing a box around the planet. So you can draw a fairly small box. You see here the box was 368 by 344 pixels, even though the 294 camera has a huge 4/3 size chip on it. I was just using a very small fraction of that. The main controls are the gain and the exposure time in milliseconds. And again, what I tried to do is to use similar gain and exposure times in order to maximize the frame rate. So for example, here the gain was 308 and the exposure time was a little over 4 milliseconds. And again, for the exposure time here, you can set just any different exposure time you want, but again, I had set it for 180 seconds or 3 minutes. And it was collected an SER format video. The frame rate that you achieve is displayed right down here, and you can see for this particular run, I was able to get a frame rate of about 117, 118. The maximum frame rate could have been as high as 226, but that would have required a USB 3 port. And again, I was using an older laptop that only had USB 2, and so I wasn't able to get the best possible frame rate. Importantly, for both of these programs, they both display a histogram, and the histogram allows you to adjust the exposure using the exposure and the gain in order to achieve a histogram that's properly exposed but not overexposed. So what I usually shoot for in the exposure is to get the histogram at about 80% on whatever the brightest channel is. And you can see here the red channel is a little brighter because of Mars. And so I was trying to hit right around 80% for the histogram. That gives me the correct amount of exposure. One of the other things that is available in FireCapture, it has a special display for the atmospheric dispersion corrector. And so if you check the little box here for the ADC tool, it brings up another window here with a couple of displays for the 2 different polarizer filters. And this makes it pretty easy to adjust the polarizers. You just keep twisting around on the little knobs until these 2 circles line up as much as possible. Sometimes they line up perfectly, but in general, because the images are bouncing around because of the seeing, they don't always line up perfectly. So sometimes this is the best you can do, and sometimes you can get them to line up exactly one right over the top of the other, and that kind of tells you that you've eliminated the red blue distortion that occurs because of the planet being low in the sky. The good news for Mars is that Mars is very high in the sky for this apparition, and so you don't really need to have an ADC. So if you don't have one of those, don't fret, because if you shoot Mars when it's, you know, close to the zenith or close to the meridian, it's going to be up at 60 or 70 degrees altitude, and there's going to be very little color abnormality because of the atmosphere. But again, one of the nice features of FireCapture is it has this tool that's built in that kind of lets you adjust that for planets that need it. Okay, and this is the screen that you see for SharpCapture. I know a lot of folks use SharpCap, and you may be a lot more familiar with it than I am. But again, the controls for planetary imaging are fairly similar. Again, there's a display of the image as it's being collected, and you have the difference here is that the region of interest is selected from a drop-down menu, and you can see I've selected the smallest subframe of the chip that was available, and that's 320 by 240. And you can see here on the display, that's a very small center section of the chip. So the difference, one of the difference between SharpCap and FireCapture is for SharpCap, you have to get the planet centered pretty much on the chip, and then you can pick a smaller capture area and make sure that the planet falls within that that small subframe. It's a little bit more difficult to do that, and one thing that I did notice is that if you have any optical abnormalities in the optical train, like dust particles on the Barlow lens or on the window of the chip, if one of those abnormalities happens to lie close to the center here, that causes you have to move the planet around to make sure there's not a dust bunny or something interfering with it. So again, there's a little bit more of a constraint there, but that's something that's pretty easy to do once you get the planet centered on the chip. The main controls are similar to what you see in SharpCapture. You have an exposure time and a gain rate. And again, the idea is to adjust the exposure time down and the gain rate up so that the histogram shows that you're getting about 80% exposure in whatever the brightest channel is. Again, the histogram on this screen display is down off the screen here, so I just drug it up here to the screen so that you could see it. But again, you adjust the exposure and the gain to try to get the histogram to peak out at about 80%. On SharpCap, the frame rate reads out down at the bottom here, and you probably can't see that, but you can see here I'm getting a frame rate of about 150 to 153, which is a really good frame rate, again, using the old USB 2 ports. SharpCap also gives you an indicator of how many frames are dropped, which is helpful because if you haven't adjusted the frame rate too fast or your USB isn't keeping up, you'll get a lot of dropped frames, and that's usually an indication that you need to slow down the frame rate a little bit so that you don't lose a lot of frames. But as you can see here, no dropped frames for this particular SER run. So again, that's just a comparison of the screen display that you get in the two software packages. They're fairly similar. And now we'll look at some of the results.
Hey, Greg, before you move on to that, can I ask a quick question on mechanics?
Sure.
When I define a small ROI, I would expect my frame rate to increase. It doesn't. And I'm now hearing your discussion. I'm guessing that's because I would typically set the gain at 200 and adjust the exposure upward till I hit that sort of 75 or 80% mark on the histogram.
Yeah, as you turn the exposure rate down, you're taking the frames at a faster rate, and typically you have to then push the gain up. As the gain goes up, you get a little bit more noise in. But for planetary imaging, where we're doing lucky imaging, what you usually want to do is you know, have the gain not at 100 all the way up as high as it'll go, but high enough that that you get a decent display on the histogram. You use the histogram to really pick it out. So yeah, you should get a higher frame rate as you pick a smaller region of interest.
Yeah, I suspect my exposure times were long enough that was the constraining factor then.
Yeah, what if you can have a longer exposure time and turn the gain down, but for planetary imaging, you kind of want to pick a sweet spot for the two of them.
Right.
And again, the sweet spot is the highest frame rate you can achieve with the appropriate amount of exposure on the histogram.
Can I ask one more question before you move on?
Sure.
In FireCapture, but also in SharpCap, take Jupiter as an example, it's coming up very blue-green. And I think I can adjust that later in AutoStat with the, you know, adjusting the channels on the histogram. I know that you do it checking the debear option on FireCapture. Does that debear individual frames, or is that really for the purpose of preview in the?
Let me back up to that. I'll show you. Here's what he's referring to. I've checked the debear. So when you're just looking at the frame, when you're not actually capturing it, it debayers it. But if you hit this little drop down here, there's a whole bunch of settings. And one of the settings is to turn off debayering while you're collecting the video. So if I actually had a video to show you, you would see that the planet is not debayered. It just basically looks black and white. Once the 180 seconds is up, then it goes back to showing you a color image.
What does ROI stand for?
Region of interest, subframe.
Okay.
Okay. And again, in FireCapture, you draw a box using the cursor. You draw a box around the planet. I could have drawn a smaller box around Mars here, but at some point it doesn't increase the frame rate a whole lot. So you want to have a small enough box that you have a high frame rate, but not so small that the planet bounces around and goes off of the screen, because that kind of messes up the video when you go to process it. All right.
Question.
Yes.
In FireCapture, does the region of interest follow the planet? I can't get mine to hold still. It's slowly over, seconds. It drifts.
In FireCapture, you can do that. One of the controls up here, I'm not sure which one it is. One of these, I think it's the one here, the second one. If you click on that, FireCapture will identify the planet. And then if the planet drifts during the video capture, it will attempt to keep the planet centered in the frame, even though it's drifting on the chip. So it kind of moves the subframe around, excuse me, to keep the planet centered. If you've got pretty good polar alignment, the planet will stay fairly centered. Mine drifts a little bit, but I use my hand control set at the lowest rate to basically just bump the planet a little bit back and forth if it tends to drift. And so again, it depends on how good your polar alignment is. But FireCapture does have the ability, if you click on one of the little device up here, it draws its own box, or it puts some markers around there, and it then follows the planet during the video capture.
Great.
Okay, so we'll start with Jupiter. FireCapture on the left, SmartCap on the right. You can see here the frame rate for FireCapture, the best I got was 63. For SharpCap, I got it up to 57. You can see the gain was almost the same for the two. I set it that way to try and make it as even as possible. And then again, for each of them, I collected, well, for FireCapture, I used an AVI. For SmartCap, I used an SER because it seemed like the SER got a slightly better frame rate. But you can see the final processed images are very similar.
And Greg, they're both spectacular.
Yeah.
Yeah, they did turn out pretty good this particular night. And as you can see, I took the FireCapture first. The red spot is just beginning to show up. And then by the time I switched over and got everything ready to go in SharpCap, half hour, 20 minutes later, the great red spot had rotated a bit. But you can see basically the the detail is fairly similar. SharpCap is maybe just slightly better. But again, keep in mind that the seeing can change rapidly in the space of a few minutes. And so some of the differences between images, I almost have to attribute to the change in seeing. So, but in this particular set of images, I think shows that they're pretty similar. Next, I shot.
This is Bob Lyman. I have a dumb question to ask, but when it says frames at 25%, does that mean you only were able to keep 25% of the total frames and the 25%
Yes.
is like 1,400?
Yes. In
Okay.
other words, for each of these, I collected 3 videos. I stacked the best 25% of the frames, and that ended up being 1,400 frames for SharpCap on the left here. For some reason, I used 50% for FireCapture because it looked like the data was really good, so I thought I'd bump it up. But as you can see, the SharpCap actually looks a little bit sharper to my eye. So I may have included more frames than I should have by picking 50% here. But yeah, when I stack these in auto stacker, you can pick how many frames you want or what percentage of frames.
So
And so-
it goes through an evaluation process for you then.
Right, it goes through and it grades the images, and then it sorts the images in ascending order from the best frame to the worst frame. So when you pick the best 25%, it uses the best 25 frames after it's graded them.
How long does it take the stacking process in terms of computer time? Since it's a small portion of the chip, I'm assuming that it goes pretty fast.
It goes pretty fast. For what slows down auto stackered is using the drizzle mode. And remember, I said I used the 1.5x drizzle mode. That slows it down quite a bit because it not only has to align the alignment points, but it has to then boost those up and fill in the missing pixels to enlarge the image. But it does a really good job of that. For these, for Saturn example here, it might take 2 to 3 minutes to process the image.
Okay, thank you.
All right.
Yeah, looking at your 2 images here, looking at the SharpCap one in the Cassini gap towards the backside of the ring, I can see it's much sharper in the SharpCap and the FireCapture. It blurs out more.
Yeah.
That's where I can really see the
unfortunately,
difference.
I thought the FireCapture looked better, and so I stacked 50% of the frames. So you can see 3,300 frames instead of 1,400. The FireCapture on this particular run, I got a slightly higher frames per second, even though the gains were fairly similar. But again, as you can see, sometimes having the most frames is not always the best thing to do. Sometimes it's better to pick a smaller number of high quality frames than to use all of the frames. So that's probably one of the reasons why this one is not quite as good as the one from SharpCap.
Greg, as I
Yes.
recall in AutoStacker, you can do multiple, you can do 10%, 25, 50, all in one go.
Yes.
And that way then it would take longer, of course, but
Yeah.
then you could look at the results and then choose the one you like the best.
Yeah, in AutoStacker, it allows you to not just pick one parameter, but you can pick the number of frames, and you can do like 6 different numbers, or you can do 6 different percentages, and it will stack it in all those ways. And so then you can go back and see which one you like the best. You can also, and what I did for these images is, once you look at one image and decide how you're going to stack it, you can just select all the images from that run and stack them all the same. So you can pick 5 or 6 images and just walk away, and it will stack each one sequentially according to whatever parameters you've set up. So it's pretty much automated.
Greg, do you use the Sharpen feature in AutoStacker or not?
No.
Okay.
It's there just to let you see what's going to happen if you would sharpen it, but the sharpening is usually done later on after you apply wavelets in Registacks.
Okay.
So this is
Greg,
yes.
Greg
Yeah.
is Bernie. I'm sorry, I came in just a few minutes late. Could you very quickly explain the drizzle function in 30 seconds or less?
I'm sorry, say that again.
Could you explain the drizzle function? I missed that.
Yeah, the drizzle function is a way of enlarging the image by rotating it slightly and then having the software fill in the pixels that are created when it's enlarged. So it's used, it was kind of popularized by the people who process the Hubble images, but it tends to give you a slightly larger image, and it tends to smooth out the data a little bit so that the images look just slightly better. At least to my eye, they look slightly better. Not all the images will handle drizzle well, but if you've got pretty good quality data, the drizzle function helps quite a bit. If you Google drizzle image processing, you can get the whole mathematical algorithm that's behind it. And it's there's a whole bunch of different ways of doing it, but it is built into AutoStacker, and it seems to help. If you remember the article that I passed out last summer from Christopher Go, he uses drizzle a lot, and he kind of convinced me to try it, and I think it does work. So,
but no dithering. No dithering is required for the drizzle. I thought that was sort of a requirement.
No, not really. Not for planetary imaging.
Okay.
Because you're taking the images so fast,
Right,
in a few milliseconds.
I would think without the dither, maybe they're relying on the fact that the planet at that scale is shaking a little bit, so you're getting a little unwanted dithering.
Exactly. It's going in and out.
I would guess that's it.
Yeah.
It's moving around, and the whole idea behind stacking, for Mars here, I think I collected about 27,000 frames, or something like that. So you're really, relying on the fact that when you sort the frames and pick out the best ones, you're really taking advantage of what we call lucky imaging. It's really the luck of the draw. So this is the last comparison. And you can see here, FireCapture on the left again, SharpCap on the right. Again, I used 25% of the frames. The frame rate that I was able to get on SharpCap was a lot higher. I'm not sure why that was. The gain was a little higher as well. And so I ended up with quite a few more frames in SharpCap than in FireCapture, but the final processed image in FireCapture looks a little better. And I think that's probably due to the fact that there was some change in the seeing between when the first first run was made and by the time I switched over to SharpCap. The other thing that I'd like to point out is this: when I set up the region of interest, SharpCap puts this timestamp at the top, and you may have noticed that on the frame earlier, and it kind of gets in the way when you do the drizzle. And so you can see it created this giant wart on the top of Mars here because the processing tried to process the timestamp at the top. So again, if you're going to use SharpCap, you want to make sure that you keep the planet disk pretty far away from that timestamp I could,
off.
there may be a way to get rid of that, but
Yeah.
I'm not familiar enough with SharpCap to do that, but I suspect there's a setting somewhere so that you don't have to have that on the frame. Does anybody know?
I use SharpCap exclusively and I've never seen it. So
Really? So
Same
there is
here.
a way to get rid of it.
I've never seen that come up, so I haven't stumbled onto that setting.
Okay,
Yeah,
well, don't
up-
change your settings.
Yeah, up under the file, there's a SharpCap settings tab, and it will bring up a whole bunch of things. Even the simpler one is so you can change to the night vision.
Yeah,
Uh,
I looked through the settings and I couldn't figure out how to get rid of it. So I left this in just as a warning. If you use it, to make sure that you keep the planet pretty well below the timestamp, because when you go to process it, the timestamp kind of gets processed in with everything else and it can ruin an otherwise very good image. So again, I think the difference between the data that you see here is probably due to change in the atmospherics, because we got a lot more frames captured with SharpCap than we did with FireCapture at this particular run.
Hey, Greg, quick question
Yeah.
from Kevin. On Mars, you did a single sequence of 180 seconds. Jupiter was 3 sequences of 30 seconds, and Saturn was 3 of 60. What's
Yes.
the reasoning for doing one long one versus breaking it up?
Well, the Mars doesn't rotate as quickly as the other two. So you can take a longer AVI of Mars before the planet rotation causes smearing of the features.
Which
So
would
for
take
my
the
focal,
same total time, right?
I'm sorry?
Well, I mean, in the case of Jupiter, you did 3 30-second series. You
Right.
could have done a single 90. It's going to rotate the same amount of time over 90 seconds, right?
No.
No,
No.
what am I missing here?
No, it rotates fast enough. I'm using about 6,000 millimeter focal length. And at
Okay.
that focal length, anything more than about 30 to 45 seconds is going to show some smearing of the features. So by taking 3 shorter ones and then superimposing them or letting WinJupos combine them, WinJupos basically derotates those images. It picks the middle image and it makes the other two match up.
So you process that center series first, and then it brings in the previous 30 seconds and the later 30.
You don't, WinJupos will, no matter how many images you have, you can throw 10 images in, and WinJupos will try to derotate them. Now, if you wait an hour between the images, it's not going to do a very good job of derotation. But if you take
Okay.
3 30-second AVIs, one right after the other, it can derotate those pretty well. And at the same time it's derotating them, it's stacking them. So you get the benefit of noise reduction that comes from stacking 3 images as opposed to just processing a single image.
Okay.
So to conclude, these are my conclusions, that the two packages pretty much do the same thing and pretty much allow you to capture planets in very similar ways without too much trouble. The framing of the planets is a little bit easier in FireCapture because all you have to do is get it on the chip and then draw a box around it. So it doesn't have to be centered on the chip. That makes it a little easier to get started. But the main thing, I guess, is that you need to try to get the highest possible frame rate based on the region of interest, the exposure time, and the gain. And again, need to look at the histogram to try to make sure that you don't over or underexpose. It's better if it's a little bit underexposed because you can always boost it up a little bit post-processing. But if you overexpose it, that overexposed portion is basically gone. And if there's any detail at all in it, that detail gets lost. So lastly, the local seeing and atmospheric stability changes a lot from minute to minute. And so I would encourage you to go out and point your scope at Mars. And if it looks like it's bouncing all around and you can't see much detail, keep looking, because, you know, if you wait 10 minutes, it may settle down quite a bit. The higher in the sky it is, the less atmosphere you're looking through. And you probably are going to have some good results, because Mars is as big as it's going to be for the next few apparitions, I believe.
Doug, Greg, this is Bob Langland once again. I got kind of a dumb question, but are either one of these software packages capable of working with a standard Canon 6D, or like I've got an RA that is capable of doing video, but I don't know if I could use it with these particular packages. Do you know anything at all about that?
I'm not sure, but I believe you can.
I'll be darned. Okay.
Each of them has a drop-down list that lists some of the more popular cameras. For example, if you have one of the regular planetary cameras like a ZWO camera or a QHY camera, and you have the proper drivers installed and you have it plugged into your USB port, as soon as you open the program, it'll find that camera for you and you're ready to go. And I'm pretty sure you can use it with a DSLR. You may have to use one of the Windows video drivers in order to do that, but as long as that video driver works with the video on your camera, it should work.
Okay,
Whether or not you can draw boxes around it to get the region of interest, I'm not sure about that. That you'd have to try.
Okay, thank you.
Any other questions?
Hey, Greg, this is Kevin again. I know this exceeds your SharpCap versus FireCapture, but when you get to Registacks, what's your philosophy on working through the wavelets? Do you go from fine scale to large scale, or the other way around?
I pretty much follow that guideline that I mailed out from Christopher Go. He uses the very simple wavelets, the linear wavelets, and he only uses levels 1, 2, and 3. Okay. The higher levels, work on bigger objects, and they make, the bands on Jupiter darker, but they don't add a lot of detail. Most of the detail comes from the smaller wavelet. And, I tend to kind of stick with those and then do the final sharpening in some graphics program like Photoshop.
Greg, could you email that out for us?
I'm sorry?
Could you email that guide out to us tonight?
Yeah, it's on it's located on our Dropbox, and it's also, well, maybe it's not on the Dropbox anymore. I've moved a lot of the meeting materials to